Okay, so I wanted to show you a little around the 6.6 homework and how it looks from the computer. First of all, I've opened 6.6 homework, and it says the first question, the ratio of the vertical change to the horizontal change for any 2 points, that is called the slope of a line. That's the vertical change, how much it goes up and down, the y change over the x change, the horizontal change. So we call that the rise over the run, or the slope. Oh, I've got to finish that. Okay, next we're going to talk about the 3 methods to graph a line. Most of the time in class we spent plotting our points with an XY table, so that's always a good way to graph a line. So you can always fall back to that, but there's other methods. The second method is very much related to plotting points. It's using the intercepts, but it's more specific. Whenever the question requests that you graph the line by the intercepts, you must use the zeros. The 0 for x to get the y-intercept, and the 0 for y to get the x-intercept. So those specific 2 points, the computer would be programmed to expect those to be the 2 plotted points if it requests that. Then the third way is using the slope and the y-intercept. Anytime a linear equation is solved for y, you'll be looking at the slope in front of the x and the y-intercept for the constant. So those are our 3 methods to graph a line. All right, and then here is the y equals mx plus b form. Anytime a linear equation is solved for y, you're looking at the slope in front of the x and the y-intercept on the end. So it's asking you what represents the slope, but that's the m value in front of the x, so m for slope. Then it talks about quadrants. So let's look at a quadrant. Whenever you're looking at a graph, it divides into 4 sections, so they call these quadrants. This is called the first quadrant. When the x values are positive and the y values are positive, that's quadrant 1, then quadrant 2, 3, and 4. So it moves counterclockwise, 1 starting in the positive quadrant. And then you have some practice problems where you are practicing and used to plotting points on this program. I'm going to skip on over to question number 9, the first real graphing question, where we have x equals a constant. This is a special case of a line. X equals is a vertical line, so you just need to memorize that, and that's in your notes. X equals is vertical, so we click on this to open up our graphing tool, click on the line, go to x is -6, click there, and then draw it vertically. Just pick any point above or below to keep it stabilized and vertical. Now, if you use the slope formula to do the rise over the run there, you'll find out that you get a 0 denominator. So anytime you have a vertical line, the slope is undefined. You can just write that on your note card to remember that when you test. Okay, y equals is a horizontal line. Anytime you're missing the x and you only have the y equals, that's another special case of a line, horizontal. So we pick up our line tool, we go to y equals 2, and then draw anywhere beside of it to make it a stable horizontal line. So any 2 points is going to draw the line in this program. Now the slope of a horizontal line is 0, always 0. If you use our slope formula, which is subtract the y's over subtract the x's, you're going to find out you get a 0 in the numerator for any horizontal line. When you subtract the y values, they 0 out on top in a horizontal. All right, so here's a normal line. It has a different slope to it, a particular slope in front of the x. Anytime you solve a linear equation for the y variable, you're looking at the slope is in front of the x and the y-intercept on the end. So you can graph by that method, or you can go back to point plotting. Really, either way works here, and I encourage you to use whichever method you prefer. But since this is solved for y, it's kind of handy. You can go to the y-intercept, which is go to the y-axis, find -2. Again, that's the number on the end if it's solved for y. Then the slope is in front of the x. The slope is the rise over run from point to point. So in this case, you don't see numbers. They're understood to be ones. So you've got a 1 over 1. So that would be from your y-intercept, rise 1, run 1. Click, and it draws your line. Okay, another example, this time again solve for y. So your slope is in front of your x, so the slope is 2 or 2 over 1. Since you don't see a denominator, it's over 1, and a y-intercept of -1. So to graph, we pick up our line, we start at the y-intercept, which is -1. Then this is a rise of 2 and a run of 1. So notice I go from the y-intercept, rise 2, +2 over +1. This one is not solved for y, but it's only got a regular 1y here in front of it, so all we need to do is throw the 2x across the line. You know, when that crosses over, it makes it -2x. You may want to write that on your piece of paper to remember the slope is -2 because that has to cross over. So -2 over 1, since it doesn't have a denominator, is the slope, and then that's your y-intercept, the constant. Now, if there would have been a number in front of y, we would have had to do a little more algebra to solve for y, but this is already just y. We just need that across, then it'll be mx plus b. So to graph, we start at the y-intercept of -3. We rise -2, which will be down 2, and we run +1. All right, here's a slope that is a fraction. We can see two numbers, the rise of 1 and the run of 3, and the y-intercept's -3. Again, we can use this method because it's already solved for y. So we pick up our line. We start at -3. This one has a slope of 1 for the rise, run of 3. So up 1 over 3, both positive here. Notice that's how a positive slope will look. It'll look like it's rising as you read from left to right. It's a rising slope, a positive slope. All right, notice the directions changed here, and it says to graph with the X and Y intercepts. And the next few problems are going to request the intercept method. So this is a little harder to show on the computer screen without writing on the board, but you will make a t-table. You'll draw a t-table, and you'll plug in 0 for X, then you plug in 0 for Y to find the two intercepts. So maybe we can kind of talk through this. If we plug in 0 for X on this one, it solves fairly easily because if you zero out the X, you just have a Y, and it's a positive 1Y equals -6. So that's your Y-intercept. Let's go ahead and plot that. 0 for X, -6 for Y. And notice in the right-hand corner of your screen, it verifies I'm at 0x, -6 for y. You see that was right up there. It changes as I move it, but notice that point is correct. Then I need the x-intercept. For the x-intercept, you plug in y as 0. So for this, it's also fairly easy because there's just a 1x there, a positive 1x. And if you zero that out, you're looking at x equals -6. So x is, let's see, there's -6 when y is 0. And there's that point. So again, that's your x-intercept, where your line crosses your x-axis, x-intercept. And this is your y-axis, and this is where it crosses or intercepts the y-axis. So graphing by the intercepts is the two 0 values, 0 for x, 0 for y. Then you have a few of those. I should have asked more of the others. Let's see. There's still x and y intercepts. All right, then there's one just using the slope formula. Then we get back to graphing again. Graph using the slope y-intercept, which is what I've been actually doing. You can use point plotting or the three methods on the others, but I have been using that y equals mx plus b form. I kind of prefer that. I think it's easier, especially if it's already solved for y. So here we have a slope of 1 or 1 over 1, and then a y-intercept of -2. So we start at the y-intercept -2, rise 1, run 1, click. Fantastic. All right, here's another one solved for y. Y equals, there's your slope of 3 in front of your x and your y-intercept -2. So we start at the y-intercept -2, rising 3, running 1, since it's understood to be over 1 if you don't see a fraction. Okay, here's a nice fraction slope, a rise of 6 and a run of 7, and they're both positive. Hopefully we'll have an example where we have a negative. If there would be a negative, you can use it on the top or the bottom. Just don't double use it. But these examples have all been positive. So that's up 6 over positive 7, starting at -2. So I start at -2 and then rising 6, running 7. Oh, okay. I hope I can see that. I think that's correct. Let's see if it is good. All right, now this one switches gears and we actually have to figure out the equation of the line from the picture. So it has it graphed. So we're going to work backwards in this, and I'm going to pick out, this is my y-intercept at +3, so I know it's going to have a +3 on the end. Then in front of that, I need to put my slope. Remember, it always has the slope in front of the x, so I'm going to have an x there. And then let's figure out, and you can use any 2 points on this line. You could do up 1 and then back 2, so it'd be +1 over -2, or you could say it's -1 over +2, whichever perspective. Or you can do from here to there. The slope is the same whichever 2 points you use along this line, but there's a definite slope of -1, +2, or a negative fraction. There's a negative involved, and anytime you see the slope is going in this direction, downhill, that's going to be a negative slope. So that kind of helps you clue in there should be a negative involved. Let's see what I say. It was down 1 and then over by 2. So my slope is -1/2 for that. Okay, we can do that again. This time I have to write in my own y equals. Then I need to have something x plus the y-intercept. Here's my y-intercept. This example crosses at +5, so I know it's going to have a +5 on the end. Then I need something in front of my x. So the slope from any 2 points, let's say I'm going to go from here to here, and from here it goes up 1, 2, 3, and over 1. So 3 over 1, or just 3. I don't think you'll have to show the over 1 there. All right, I'd also like to demonstrate, let's see, let me get out of this. I'd like to demonstrate just a couple of problems, if we can, over 6, 7. I think it times out on me at 15 minutes, so it won't let me talk too long. All right, so let's do just a couple problems from 6, 7, where, let's see, it won't let me go ahead. Where it asks you to solve a system. So I'm going to ask you a couple of questions just from 6, 7, just as far as graphing these 2 lines. So figure out where these 2 lines intersect, and that's your solution. So it's really just a continuation of the graphing. So we're going to graph this first equation. Let's see, let me pick this up. X equals 2, that's a special case, over 2 and vertical, when it's just x equals, draw a vertical line. Then I'm going to pick up the line again and draw this second equation, y equals 4, which is your horizontal line through 4, so draw a horizontal line. So you're just going to graph 2 equations on the same graph on this 6.7 stuff. And then the solution is where they cross. So you'll look at your graph and say, what's this point of intersection? Over 2, up 4. That's your solution. Parenthesis 2, 4 is where those 2 equations graph cross each other. And that's how we'll do that. Let me move over to one that has a different slope on it. So again, here we're graphing this first equation. Then we start over, graph this second equation. So it's just what we did on the last section, just do it twice. So for the first line, I solve for y, so that's your slope, y-intercept. So y-intercept -4. Then the slope is 3, so that's up 3 over 1. That's that line. Then we pick up the line again and draw this second line. And it's solved for y as well, so we can start at the y-intercept of -4. And it has a slope of 1, which is 1 over 1, up 1 over 1. Draw that line. So I've got 2 different lines graphed. So just doing what we did before, but doing it twice. And then look for where they cross or intersect. That will be our solution. And it asks for the solution. So it looks like it's 0 for x, -4 for y. If I was hovering over that point, it should tell me it's 0x, -4 for y. Let's see if we have time to just mention this next one. So again, these aren't solved for y. We know sometimes that happens. You have to either use a t-table and do the point plotting, go back to that, or solve it for y. Throw this x across the line, and it would make it a -x. So you'd use your slope-intercept method if you want to solve it for y, or you can do the t-table method. But you'll graph each one of these lines on the same graph and see where they cross. Now, if they don't cross, that means they could be parallel. They could be an inconsistent system. Parallel won't cross. Or they could just be the same line, which they're not. You can tell they're different lines. Where they lie on top of one another, that's dependent. So we'll come back and talk about that a little bit more later. And I hope that helps, and wishing you the best.